In this lesson, we're going to take a look at exponents with the same base. We're going to learn how to simplify these expressions using the product or the quotient rule. Power rules are applied to simplify exponential expressions. Simplifying an expression simply means that we're going to reduce the number of characters, making our expression more compact and efficient to use. And we will do this without changing the actual value of the expression. And the two power rules we're going to focus on in this lesson is the product and the quotient rule. Remember, product indicates multiplication has been applied, and quotient means division has been applied. We're going to first look at the product rule. So we have x to the m times x to the n. Since we have x's as the base on both of these factors, we can rewrite, instead of having two factors, we can write it into one, simplifying the expression. And when multiplication is occurring, the rule says to add the exponents of the like bases. Let's take a look at this and let's prove the rule by expanding each expression. So we have a squared times a to the third. We have two factors with the same base, so we can really put this together as one. But let's expand a squared into what's really going on. A times a times, then we have three a's being multiplied. Now we can regroup this, rewrite this as a to the fifth. So we went from two factors to one factor. That is simplifying. 2 plus 3 is 5. Now let's take a look at this expression. 2 squared times 2 to the fourth. Our bases are the same. Let's expand this exponent. 2 times 2 times 2 to the fourth. And now we can rewrite this as an exponent, 2 to the sixth. So 2 to the second times 2 to the fourth can be written as 2 to the sixth. We went from two factors to one factor. So again, when you're multiplying two exponents that have the same base, you add the exponents. Okay, now let's practice these problems without expanding and just applying the rule, which says to add the exponents. So we have c to the eighth, 5 plus 3. M squared times m to the negative fourth. We have m, 2 plus negative 4 is negative 2. Now remember, on our previous lesson, we learned that we do not need to leave an exponent as a negative. So we're going to have to reciprocate and move m to the negative 2 to the denominator, giving it a positive exponent. The next one, we have z to the negative 3 times z to the negative 1. We need to add these exponents. And now we need to simplify the negative. So we went from two factors to one factor. On the next examples, we have variables, but we also have coefficients. So since all of this is being multiplied, and we can apply the commutative property, so I'm going to rewrite these so that our coefficients are together and then our variables are together. Once you do this a few times, you do not need to rewrite this. You could see that 2 times 3 is 6. But just for now, let's go ahead and write our like factors together. So we have our two coefficients, 2 times 3. And now we're going to apply the rule, the product rule. A to the third times a to the fifth. You add exponents, and we get a to the 8. 6a to the 8th is our final answer. Our next example, our two coefficients, 4 times 2. Then our factors of b. There's an understood one here on the b. So anytime there's no exponent on a variable, I always like to write it in so I don't forget it. So we have 4 times 2 is 8. And then we're going to have negative 1 plus positive 1, b to the negative 1, times b to the positive 1 gives us b to the 0. In yesterday's lesson, we learned anything raised to the 0 is 1. So we get a final answer of 8. Now this 0 is only attached to the b. It is not attached to the 8. The 8 still has its value of 8. In our last example, negative 3 times 2 times k squared times k to the negative 5th. We're going to multiply our coefficients and get negative 6. We're going to apply the product rule. We have k squared times k to the negative 5th. That's going to be k to the negative 3. This negative 3 is only attached to the k factor, so our negative 6 remains in the numerator, and we move the k to the negative 3rd to the denominator, giving it a positive 3. Okay, on these, pause the video and then come back and we'll go over these. Okay, number 1, we're going to get 9 to the 2nd. And sometimes it may say go ahead and evaluate. So since this is easy to evaluate, I'm going to go ahead and evaluate it. But this is the simplified form. This is the evaluated form. Number 2, we're going to get q to the negative 8. And we do need to reciprocate. Number 3, we have a squared times a to the negative 3. So we have 2 plus negative 3. That is negative 1. Then we have b to the negative 1 times b to the 1. That is b to the 0. So a to the negative 1 gets moved to the bottom and becomes a to the positive 1. B to the 0 is 1. And this is our final answer. Number 4, we have 2 times 3. That is 6. We're going to apply the product rule. Negative 3 plus 2 is negative 1. The negative 1 is only attached to the x. So we have 6 over x to the positive 1. You do not need to write in a positive 1. Number 5, we have 5 times 3. That is 15. We have g to the 1 plus g to the negative 4. So we have 1 plus negative 4. That's negative 3. Then we have a factor of h. H to the negative 2 plus 1. So negative 2 plus 1 is negative 1. So the 15 has an understood exponent of positive 1. This negative 3 is only attached to the g. This negative 1 is only attached to the h. So 15 remains in the numerator. And they're going to move g to the positive 3. And h to the positive 1 is in the denominator. And number 6. 4 times 5 is 20. Then we have a factor of d and a factor of e. So negative 4 plus 4 is 0. 5 plus negative 2 is 3. So we have 20 times d to the 0 is 1 times e to the 3. We don't need this 1. So again, remember, we're simplifying. You're condensing the expression using as the least amount of characters as possible. That's our final answer. Okay, now let's go over the quotient rule. So product and quotient, they represent like inverse operations because, with product you multiply, quotient you divide. So the product rule was to add. So you can imagine that the quotient rule, so the inverse of adding, is subtracting. So the quotient rule is subtracting exponents. So you can see we have two different, or they're the same bases, but we have two factors, and we can turn it into one factor. We can simplify. So the rule for the quotient rule, when we are dividing factors with the same basis, you subtract the top exponent minus the bottom. So it's the top minus the bottom exponent. You have to do it in that order. Top minus the bottom. Okay, let's expand and prove the rule. So we have x to the 4th, which when we expand, we are multiplying x 4 times. X to the 3rd, we are multiplying x 3 times. And anytime you have anything over itself, it cancels out or you really get 1. So I'm canceling this. This is where the subtraction part comes in. So I'm subtracting out pairs. And we were left with x to the 1, or just x. and you can see 4 minus 3 gives us that 1 exponent. In our second example, we have 2 to the 5th. We have 2 to the 2nd. We're going to subtract out the pairs, cancel those pairs, and we are left with 2 to the 3rd. 5 minus 2 equals 3. Notice I'm doing the scratch work with subtraction because we will be adding in some negative exponents, and it is very important that you don't make a sign mistake. So I like to write out my scratch work when I am applying the quotient rule. Let's do these together. So we're not going to expand, we're just going to apply the rule. So every time I'm going to do my scratch work, 7 minus 3 gives me 4. Our next one, we have k. So we have negative 4 minus 2. Keep, change. That gives us k to the negative 6. We must simplify the negative on the exponent. And when you move the factor to the opposite location, we must take off the negative. That's the whole point. So k to the negative 6 is the same as 1 over k to the 6. Our next example, we have a factor of m. And now here, super important, a lot of people will jump to say, oh, that's 3. But look, 5 minus negative 3. Keep, change, it's really positive 8. So do not get in a hurry. Do the little scratch work. It's worth it. Okay, it's worth getting it right, just taking a few seconds. Okay, so now we're going to look at where we have some coefficients. So what I like to do is separate. Here's my coefficients, and here are my variables. So 12 over 3 is 4, and now I have a factor of a. So 3 minus 5 is negative 2. Now this negative 2 is only attached to the a. So our final answer is going to be 4 over a squared. We have 18 over 24. And you don't have to separate them, but especially when you're learning, you might want to. Okay, 18 over 24, this can be simplified with a factor of 6. So we get 3 over 4. Then we have a factor of w. 5 minus negative 3. Keep, change gives us positive 8. So you probably will see it written as this, as your final answer. Okay, pause the video and then you try these, and then we'll come back and go over them together. Okay, number 1, we're going to have h, negative 2 minus 6, keep, change. We have a negative 8, and then we have to flip that to the denominator. Number 2, it's not 0, it's not 3 and just negative 3, it's 3 minus negative 3, keep, change, gives us positive 6. I'm going to put a 1 on my a here. So we have a, 1 minus negative 3, keep, change, a to the power of 4. Then we have a b factor, 5 minus negative 1, keep, change. We have no negatives, and we're good to go. On number 4, we have 8 divided by 2. So 8 divided by 2 just gives us a whole number 4. Then I have a factor of g, and I'll have a factor of k. Sometimes I just go ahead and write my factors down. And then I'll move them if I need to. So we have 2 minus negative 4, keep, change, an exponent of 6. Our k is negative 1 minus 1, keep, change. I get negative 2. So the 6 is attached to the g, the negative 2 is attached to the k, and 4 just has an understood 1. So the 4 and the g factor remain in the numerator, and my k is going to go to the denominator. Now let's look at 18 over 12. These are both divisible by 6. So I have 3 over 2. Then I have a y and a z factor. So for the y, I have 2 minus -3, keep change, an exponent of 5, and then I have 5 minus 4, that gives us 1. So I can write it as 3 w to the 5th times z to the 1st all over 2. I hope this helps.